mystery in space we've been following since it first appeared in our skies 3 months ago.
3-eye Atlas go from an anti-tail to a tail to a no-tail.
Here are the numbers that are keeping astrophysicists awake at night. 129,700 miles per hour. That's how fast 3-eye Atlas is moving through our solar system. 1.8 million miles, that's how far its jets extend into space. 110 billion pounds. That's how much material it would need to eject monthly to create what we're seeing. And here's the kicker, less than 0.1%. That's the probability this massive interstellar object arrived here by pure chance.
The object is quite large, and it's also aligned in its path with a plane of the planets around the sun.
When you combine that with its unusual trajectory, aligned within just 3 degrees of our solar system's plane, the odds drop to 1 in 100 million. The Meerkat radio telescope has detected radio signals from this object at 1.665 and 1.667 gigahertz, marking the first successful radio detection of 3-eye Atlas.
Most important question is whether it could be technological or it's just natural. Hopefully we'll know more within the coming days.
These aren't just random numbers, they're evidence of something unrealistic happening in our cosmic neighborhood. And I'm about to break down exactly what each measurement reveals. Subscribe to Space Aquarius and let's begin. The radio signals revealed Doppler velocity shifts of -9.7 and -9.8 miles per second, allowing scientists to track the object's precise movement through space. But here's where things get strange. The thermal broadening of these OH lines suggested surface temperatures around -45 degrees Fahrenheit, which is exactly what you'd expect from a comet at that distance from the sun. Everything seemed normal until researchers started analyzing the visual data. What makes 3-eye Atlas truly bizarre isn't just its anti-tail phenomenon. It's the complex jet structure that has emerged as it approaches the sun. The most recent observations show this object surrounded by a glowing halo extending approximately 310,000 miles into space. That's roughly 5 times the diameter of our moon's orbit around Earth. Within this massive halo, astronomers have identified multiple jets shooting material in various directions, creating a pattern unlike anything seen in conventional comets. The anti-tail jets extend outward for nearly 590,000 miles toward the sun, while a longer, more traditional tail stretches 1.8 million miles in the opposite direction. To put this in perspective, if you could see these jets from Earth with the naked eye, they would appear roughly the same size as the full moon in our sky. The sheer scale of this phenomenon is staggering, and it's happening to an object that's currently 202 million miles away from us. But the mystery deepens when you consider the physics involved. For these jets to extend such enormous distances, they must overcome the solar wind, a constant stream of charged particles flowing from the sun at speeds of 894,800 miles per hour. The fact that 3-eye Atlas can push material against this cosmic hurricane suggests something extraordinary is happening on or within this object. Harvard astrophysicist Dr. Avi Loeb has calculated that for a natural comet to create such massive outflows, it would need to lose more than 10 to 20% of its total mass near perihelion, its closest approach to the sun. This would require ejecting approximately 110 billion pounds of material per month, which is comparable to the minimum estimated mass of the entire object. In other words, 3-eye Atlas would essentially have to destroy itself to create what we're observing. The implications become even more intriguing when you examine the mass loss calculations. The outermost regions of these anti-tail jets have a mass density roughly 1 million times greater than the solar wind itself. This creates a ram pressure effect that allows the jets to push through the solar wind and extend toward the sun. The mass flux required for this phenomenon is approximately 4.4 million pounds per second across an area of 3,860 square miles. Recent observations have revealed another puzzling aspect of 3-eye Atlas. It appears to be shrinking. NASA data confirms that the object has lost approximately 13% of its material after passing close to the sun, yet no conventional comet tail has been observed. This contradicts everything we know about cometary behavior, where significant mass loss should produce spectacular dust and gas trails pointing away from the sun. The statistical anomalies surrounding 3-eye Atlas are equally compelling. Dr. Loeb's analysis suggests that the probability of such a massive interstellar object arriving in our solar system by pure chance is less than 0.1%. When combined with its unusual retrograde trajectory, aligned within just 3 degrees of our solar system's ecliptic plane, the odds drop to approximately 1 in 100 million. This raises a provocative question that's dividing the scientific community. If 3I Atlas were employing some form of technological propulsion system, the required mass loss could be reduced by 1 to 2 orders of magnitude. Chemical rockets achieve exhaust speeds of 6,700 to 11,200 miles per hour, which is 10 times faster than the maximum ejection speed of material sublimated by sunlight from cometary surfaces. Ion thrusters can reach even higher speeds of 22,400 to 112,000 miles per hour, potentially reducing the required fuel to less than 1% of the spacecraft's total mass. The color changes observed in 3I Atlas add another layer to this mystery. While most comets turn reddish as they heat up and reflect more red light, 3I Atlas has been observed turning blue near the Sun, a phenomenon never before documented in any known comet. This unusual spectral behavior, combined with its other anomalous characteristics, has led some researchers to suggest we may be witnessing something unprecedented in our solar system. The timing of these observations is particularly significant. 3I Atlas reached its closest approach to the Sun on October 29, 2025, at a distance of approximately 126 million miles. This perihelion passage triggered the most dramatic changes in the object's behavior, including the formation of the complex jet structures we're observing today. The fact that these jets appeared so suddenly and with such intensity suggests that whatever is driving this phenomenon was activated by the increased solar heating. Looking ahead, 3I Atlas will make its closest approach to Earth on December 19, 2025, passing within 167 million miles of our planet. This will provide astronomers with their best opportunity to study the object in detail and potentially resolve some of the mysteries surrounding its unusual behavior. Following this encounter, 3I Atlas will continue its journey toward the outer solar system with a final close approach to Jupiter on March 16, 2026. The Juno spacecraft, currently orbiting Jupiter, will attempt to observe 3I Atlas during this encounter, using its dipole antenna to search for radio emissions at frequencies ranging from 50 Hz to 40 MHz. This could provide crucial data about the object's internal structure and the mechanisms driving its extraordinary jet activity. What makes 3I Atlas particularly fascinating is that it represents only the third confirmed interstellar object ever detected in our solar system. Unlike its predecessors Oumuamua and Borisov, this object is displaying behavior that challenges our fundamental understanding of cometary physics. The combination of its massive size, unusual trajectory, anti-tail phenomenon, and complex jet structures creates a puzzle that may require us to reconsider what we know about interstellar visitors. The scientific implications extend far beyond astronomy. If 3I Atlas is indeed a natural object, it suggests that comets from other star systems can behave in ways we never imagined possible. This would require updating our models of cometary formation and evolution throughout the galaxy. However, if the object's behavior cannot be explained by natural processes, we may be confronting evidence of technology from beyond our solar system. As 3I Atlas continues its journey through our cosmic neighborhood, one thing is certain: this mysterious visitor has already revolutionized our understanding of what's possible in the vast expanse of space. Whether it's an exotic comet with unprecedented characteristics or something even more extraordinary, 3I Atlas represents a pivotal moment in our exploration of the universe and our place within it. The jets and anti-tail structures of 3I Atlas will continue to be monitored by observatories around the world as the object moves toward its December encounter with Earth. Each new observation brings us closer to understanding this cosmic enigma, but also raises new questions about the nature of interstellar objects and the possibilities that exist in the darkness between the stars. If you found this deep dive into 3I Atlas as fascinating as we did, make sure to hit that subscribe button and ring the notification bell. We're tracking this story as it develops, and you won't want to miss the latest updates. Drop a comment below with your thoughts on what 3I Atlas might actually be, and share this video with anyone who loves space mysteries as much as you do. The universe is full of surprises, and 3 iAtlas might just be the biggest one yet.